Hey everyone, today we are solving LeetCode problem number 1457, Pseudo Palindromic paths in binary tree. In this problem, we are given a binary tree where node value are the digits from 1 to 9. Okay, node values will be from 1 to 9, also given in the constraints. A path is a binary tree. Path in the binary tree is said to be pseudo palindromic if at least one permutation of the node values in the path is a palindrome. Okay. This is what the problem statement says, that we are given a binary tree where values of the nodes are from 1 to 9 and a path is called pseudo palindromic if at least one permutation of the nodes values are forming a palindrome. Okay, palindrome means that from the starting and from the ending it is the same. Let's say 1 2 3 2 1. If we read it from start or if we read it from end, it is exactly the same. And what we have to return is number of pseudo palindromic paths going from root node to leaf node. Okay, so we have to return the number of pseudo palindromic paths in this binary tree, and the path should go from root till leaf, not anywhere between the tree. Okay, and the path is pseudo palindromic if at least one permutation of the nodes values are forming a palindrome. Let's first have a look at the palindrome. Let's say this is 4 5 6 4 5 1. Let's see whether these nodes value can form a palindrome or not. We have 2 4, so we can place them in the extreme end. We have 2 5 5 5. We have 1 6 and 1 1. I don't think it can be a palindrome. So if I remove 1 from here, let's say we have removed 1 from here, we have only 1 6. So if we place it in between, we are able to get the palindrome. It means that except one element that is in the center, all the elements should have even number of frequencies. Let's say we have 4 4 5 4 4 5 1. So these four, we have 4 times. So we can place 2 4 on the left extreme and 2 4 on the right extreme, and we have 2 5. 1 1 in the first half and second half, and 1 1 can be in the center. It means 4 5 and 4 5 are having even frequencies and 1 is having odd frequency. And if I remove 1 also, it means all the elements are having even frequency. And after 1 I cannot add 3 because there won't be any place to add 3. It means the conclusion is that we can have odd frequency maximum one time. Maximum one node value can have odd frequency and the rest of the elements should have even frequency. Okay, so to be a palindrome, let's say for any node value set to be a palindrome, it should have at max one value as at max one frequency as 1, or you can say odd, or rest of the frequency should be even. Let's have a look at the example where we have 2 3 times 5 5 4 4. So this is also fine, where 4 frequency is even, 5 frequency is even, and 2 frequency is odd. So we can arrange it like this: 4 4 5 5 2 2 and 2 in the center. So at max one element can have odd frequency and rest of the element should have even frequency. So this is our criteria to match whether a path is pseudo palindromic or not. Okay, so first of all what we have to figure out is we have to check for all the paths from root to leaf. To check all the paths from root to leaf, what we can do is we can call DFS, and we don't have to store exactly the complete path in the series. We can just capture the frequency, because to check to check whether a path is pseudo palindromic or not, we just need the frequency count, and node value are going from 1 to 9. And if I count the frequency of each element in the path, I will be able to give answer whether that path is pseudo palindromic or not. Okay, so we are going to check all the paths from root to leaf using DFS, and while doing the iteration, we will be capturing the frequency of each element in the path. Let's say we are starting with 2. Here frequency of 2 is 1, and then we are doing the DFS, we are coming to 3. Now 3 is 1 time, and we are coming to another 3. Now 3 is 2 times. So we are coming in this way to the recursion, and while we are going back from the recursion, and here we also have to make a check that if we are at a leaf node, we will check for the condition whether this path we have captured so far is pseudo palindromic or not. So to check that, we have the frequency count, and we can directly see whether in our frequency array, which is having values from 1 to 9, that maximum one item is having odd frequency, then it is fine. If more than one item is having odd frequency, it means it is not a pseudo palindromic path. Okay, so we are directly doing the recursion, and then while returning back from the recursion, we will also reduce the frequency. So here it was 3 twice, so when we are returning from here, I will reduce it again to 1, so that I can share one hash array of size 10 within every call of this DFS path. Okay, so checking all the paths from root to leaf, count frequency of the node, add leaf, check if the path is pseudo palindromic or not. And to check whether the path is pseudo palindromic or not, we have captured frequencies of element from 1 to 9. For that, I can take a hash array of 10 size. It won't take any time and won't be counted as an extra space. So we have captured the frequency. So we will check maximum one item is having frequency divisible by 2 equal to 1. That is odd. Either all the frequencies are even, or all the frequencies are even plus one frequency is odd. That is the criteria to check for this, and we will do this processing at leaf node only. So this is our approach to solve this question. Okay, now let me directly write the code for that. You will get more understanding. First of all, I have to write a helper function where I will pass root and my hash function. What is my hash function is having? It is of size 10, and in this hash array, I will be capturing frequencies of each node value, and node values are going from 1 to 9 as given in the constraint. Okay, and at the leaf node, I will check whether this hash is corresponding to a like pseudo palindromic or not. Let me take a global variable answer to capture my answer. Answer is 0 for this call, and I have taken a hash, and also I will like update the frequency of hash root dot value plus plus, that I have captured root, and then I have called my helper function, and after the helper function I can just directly return the answer, because this answer will be updated through the helper function call. So let's write code for our helper function. Private void solution tree node root, and after apart from that hash array. Let's write the terminating case for us. If root is null, we can directly return null, return from this function. If root dot left is equal to null and root dot right is equal to null. It means we are at leaf node. Check if hash having frequencies for pseudo palindrome. Okay, I will do it later on. And if we are not at the leaf node, we have two possibility: either go to left or go to right. I will go to left even if there is any value on the left side. If root dot left not equal to null, I will go to left. But before going to left, I will capture the left element and then make call to left side. And while returning from left, I will also undo whatever I have captured. So let's say hash root dot left plus plus root dot left dot value, and making call to the left side root dot left with hash array passed. And while returning from this call, I will do the backtracking. Root dot left dot val minus minus, and I'm going to do the same thing for the right subarray. If root dot right not equal to null, root dot right value is plus plus, and then making call to the right side. And while returning from the right side, I will undo this increment because I'm taking this integer array globally against every call. And if we are at the root node, uh, I have to check whether this hash can be a pseudo palindrome or not. So for that, I will write a helper function. If it can be a pseudo palindrome, I will just increment my answer plus plus. Otherwise we don't have to do anything. Let's implement this. Can be function private boolean can be integer array hash int odd frequency. We have to capture the frequency count, odd frequency count. If odd frequency count is greater than 1, it means these values cannot be distributed in such a way that we get a palindrome value. So for every element I equal to 1 to 9, I will check frequency of each element. If hash of I divisible by 2 equal to 1, that is odd frequency plus plus. If at any moment odd frequency is greater than 1, I will return false. And if we do not have more than one odd frequency, we will return true. This function is to check whether whether this root to leaf path is pseudo palindromic or not. And in this way, we are just capturing values from root to leaf path. And in the main function, we are just calling our helper function. Let me test over sample test cases. Okay, it is working fine. Submitting the problem. Submitted successfully. Hope you understood the problem. Thank you guys.